Okay, so we're going to go over joint orientation and rotation orders, at least in video this time. The joint orients they control how your joints will rotate, essentially. And there's key joints we want to be careful to use, to make sure they're oriented correctly. And most of the others, it's not going to be as big of a concern. Okay, they still need to be oriented correctly, but they're going to be very easy to orient correctly. So by default, if you want to see joint orientation, I'm going to hide everything but the mesh for now. There's two ways to do it. And one is if you select a joint or joints and then go to Display, Transform Display, Local Rotation Axes, then you're going to see this little cursor thing pop up, which represents the joint orientation for that joint. Okay, now that one's not correct. So it'd be a good one to start with. But there's another way that I like better to just view them. So if you go to Transform, Display, and I can toggle that back off. So if I go to Component Mode, press F8 on my keyboard, and I turn off this point components by clicking on it, and then I turn on this question mark, then I can see all of it, all of the joint orients. And the nice thing about this method is if you switch back to object mode, they automatically disappear. Okay, so this is the way I recommend doing it. Now, it's helpful to have your move tool active and set to object when you're going to orient joints, because it'll be a bigger version of these is what it will do. So see, when I select that, this move tool, how it is positioned is determined by that local rotation axes. Okay, now things to look for is you want the x-axis to always point at its child. So the ankle is a child of the knee, and the ball of the foot is a child of the ankle. So if I increase the size of my cursor, I can see that this red arrow goes straight through the center of that joint, and that's good. It means I created my joints correctly. Now, if it hadn't been done correctly, that's okay. You can still fix it without having to recreate your joints. So I'm going to just go ahead and show you the ankle. It's also working, pointing where it should. And this one is as well. But if I select this one, X is pointing out here because it doesn't have a child for it to point to. So these are what we call tip joints, and we are not concerned about these joints being oriented correctly. If you are, then you can just eyeball it. Okay, you can reorient that joint manually. And that's the only way you can reorient tip joints. Now, when you're orienting joints, you want all of them on the same side of the body to be the same, oriented the same, with the exception of the x-axis pointing to the child. Now, so for you to understand that, comment the z-axis is pointing out to the interior of the body on all the ankle, the ball, and the foot. Okay, and y is pointed up as best as it can, and x is pointed down chain. That's what I mean by all the same direction. Now, if we look at the knee, it's backwards. So this one needs to be changed. Okay, so to change that, all you have to do is you can type a little mel command down in this line. And this is where you'll be glad I'm recording video. But all it is rotate space -R, and we want to rotate it 180 degrees on X. So 180 space 0 in Y space 0 in Z, and then semicolon, and then press enter. Okay. Now X is pointed down, Y is pointed forward, and Z is pointed in. So it matches up with the hip, the knee, ankle, the ball, and the toe. They all are matching now. Okay. Now I need to do the opposite with this one here. So I can reorient it. I don't have to retype that mel command. I can just press up arrow on my keyboard and then press enter. And it's going to rotate that one on X 180 degrees. Okay. So if I check my arms, they should all be the same. Z's forward, Z's forward, Z's forward. Y is up, but not on these two. So I need to fix these ones. Okay, but there's another way. X is not even pointing at its child here. So what I'm going to do is I'm going to switch out of that mode and go back to object mode. And I'm going to select this joint as an object. Then I'm going to go to skeleton, orient joint tool, and I'm going to use this to reorient it for me. So the primary axis is the axis that will point to its child. Okay, so we want X to point to the child. The secondary axis can be whatever you want, but it shouldn't ever be the same as the primary axis, though. So in this case, it's going to be Y, and then the secondary axis world orientation. So this is how it's going to orient to the world. So we can choose Y again and tell it to point up in Y. So if we look at this cursor here, the Y handle is going to end up pointing up in Y world orientation. I know this is getting sort of technical, but there's no avoiding it. And then by default, this orient children of selected joints will be selected. You should unselect that. And then click apply. Okay, now if I switch back to component mode, you can see that these two now match. Okay, so I'm going to go ahead and do this one manually. Now, I should say you can only edit these, and it's best to edit these when your rotation tool is set to local mode. You can't edit them in gimbal mode because this little cursor is determining what gimbal mode is. So you can't change its point of reference. Well, never mind. Maybe you'll have to think about that for a second. So I'm going to rotate this down to get it to match. Again, this isn't very crucial because it's a tip joint, but just so you know how you can do it. And now these match. X is pointing out, Z is forward, Y is up. Okay. So I'm willing to bet that these sides are the same. This side is the same. So there's another way you can do this. If I switch back to component mode, you can see that these are going to be different. See, Z is pointing back, Z is pointing forward on the wrist. That's bad. So here's the faster way. Once you fix it on one side, what you do is you just delete the bad side, and then you go to your mirror joints tool, option box, and maybe you'll have the same settings as you did last time. Click mirror, and now it's going to be fixed. So now Z is all pointing correctly, just like it should. Now you'll notice on the opposite side of the body, the X is not pointing at its parent. What it's doing is it's pointing exact opposite of its child. Okay? And we do that. The reason that is that way is that way when you animate, let me just show you. So if I grab both of these and rotate them in, they both rotate together, and that's called mirror for behavior. Okay, if we hadn't mirrored the joints for behavior in our mirror joints tool, then that one, when I rotated this shoulder this way, this one would also rotate that back that way. And that's not very useful for animation purposes. Okay, so I'm going to put those back. Now, on the spine joints, we want to check those and orient them correctly. So go back to component mode. And I want to make sure that Z is always pointing the same direction on all the spine joints, including the neck. Okay. So they're not. So let me just do it the cheap way, the easy way. I'm going to select each of these joints. Even though they're all green, doesn't mean they're all selected, just so you know. And actually, before I do that, I'm going to duplicate this joint here and then parent it to itself. So I'm going to go to that hypergraph hierarchy, frame it. I'm going to create a head tip joint. Okay. Now I can grab this. I'm going to turn back on my mesh temporarily. I'm going to put this at the top of the head. Now I just gave this head base joint something, a child, so it knows how to orient itself. That's all. That was the whole point of that. Okay. So now I can select all the joints more easily in here anyway. So I'm going to go to select the torso, shoulders, neck base, mid, head base. I'm going to select all those joints. I'm going to go to my skeleton, orient joint tool. Forgot I should not use that for recording purposes. So go to skeleton, orient joint tool, option box. And I'm going to use the same settings as always. Click orient. And now those are going to be fixed. If I go back to component mode, turn off my mesh. Now we've got Z pointed out the side on all of them. X is pointing to their children. This is a tip joint, so it's of no concern to me. In fact, I can go ahead and just delete it. So we don't need it any longer. Okay, but I've got something weird going on with this joint. So X is pointed the wrong direction. So I need to select that one, and I'm going to use my mel command once more and make it match. Now that's going to matter. Let me undo that for a second. I'm going to select all these joints. And if I rotate all these, at the same time, you see this kind of a weird behavior. I would expect if I rotate forward that the whole body should rotate forward. But instead I'm getting some a C shape. So let me reorient that joint real quick. Select that. Get it correct. Back to object mode. Select all those joints at the same time. And now you're going to see that it does rotate forward just like I thought it should as I move forward. Okay, so joint orientation is all about making your joints move predictably. Predictable moving joints makes for easy animation. Tongue twisters. Okay, so that's joint orientation. And then finally, I need to show you rotation orders. And for that, we want to switch our rotation tool into gimbal mode so we can see our rotation orders. Well, we will be able to see them. Anyway, and then we're going to switch. We're going to look in our attribute editor. I press Control A. And right now, my rotation order is set to X, Y, Z. Z being the, let's see, yeah. Z is the grandparent, and then Y is the parent of X, and X is the child and grandchild. Now, what's that mean? Well, you want the grandparent axes, and you can change this to whatever arrangement you want. It's a hierarchical relationship because we use Euler rotations in Maya. It's a hierarchical relationship. So you want the grandparent axes to be the most commonly used rotation. So in this case of the arm and the shoulder, Z should be the grandparent. That way you can bring the arms down and begin your animation, and the arm can still move appropriately. Okay? And then Y, you would want to be the parent, so you can swing the arm forward and back. And then that leaves X, the child, with an ability to twist the arm. Okay? Now, if I change this rotation order and mess it up intentionally, let's just do this. See what we get. I need to bring the arm down. Now I can rotate the arm forward and back still, but I have nothing to twist the arm with. So my rotation orders are off. Okay. Now the only place that you need to be concerned about rotation orders are ball and socket joints, or joints that move like ball and socket joints. Okay, so like in our class, the only two that you really are going to be concerned about are the hip and the shoulder. Now, if you wanted to go above and beyond, it would be helpful to you to go ahead and be conscious of how you set the wrist and the ankle as well, and possibly the head base joint. Okay, now again, just to summarize on rotation order, your grandparent axis is going to be you want to set that to the most common movement, the most common rotation for that particular joint. And then the parent should be the second most common rotation for that joint, and then the child should be the least common type of motion for that joint. And left to right, yeah, left being the child, and on the right being the grandparent. So it's actually opposite what you just said. And that will make the animation a lot easier. Okay, so that's joint orientation and rotation orders 101, I guess.